Hi everybody, this is Miss Kabani. Today we're going to be talking about dilutions. And what a dilution is basically you're watering down something that's very highly concentrated. I go back to the Kool-Aid example a lot. You know, if you have, maybe you put way too much of the Kool-Aid powder into your water and now the drink is really, really sweet. So sweet that it's not even enjoyable. So to counteract you putting in way too much sugar, what you can do is add water to it, and then it kind of counteracts how much solute there is in the given solvent. Okay, so remember we talked about molarity. Molarity is the number of moles in a given liter. So if you have too much of something in a given liter, it's going to be too concentrated. So we perform what is called a dilution, okay? Also from a chemistry standpoint, you know, a lot of the stock bottles that we get to do your labs are highly concentrated. You know, we'll buy like 6 molar hydrochloric acid because it's cheaper to buy that than, 1 molar hydrochloric acid. Okay, obviously as teachers it's not responsible of us to give you 6 molar hydrochloric acid in the lab. So what we do before we do the lab is we water it down, we dilute it, so that you're not handling something very concentrated. So a dilution, again, is reducing the concentration of the original mixture, and we're going to use this formula here. M1 times V1 is equal to M2 V2, and all of this is going to be very algebraic. The M1 and V1 represents the initial molarity and volume, and then the 2 represents the final molarity and volume. Okay, so the 1 and the 2 don't have any numerical value. It just means like 1 is the initial condition and 2 is the final condition. Okay, so just to show you guys how these work, all right, remember you always want to read what you're given and what you're trying to find. Okay, so here I'm given a 12 molar solution. The original volume is 0.1 liters. I don't know my final volume, and I don't know my final molarity, but my final volume is 1 liter. Okay, so to solve for M2, we're gonna do M1, we're gonna do M1 times V1 over V2. Okay, so that's going to be 12 times 0.1 over 1, which is going to be 1.2 molar. Okay, so that's my M2. Okay. In the next one, I have a 0.9 liter sodium chloride solution, and it has a molarity of 3.75. So that is my initial molarity. Okay, my volume is 0.9 liters. My final concentration, I don't know that. And my final volume, okay, they're saying that we added 1.1 liters to the original 0.9. So what we're actually going to do is add up 0.9 plus 1.1, and that is 2 liters. Okay? So again, this is because they say we added that amount. Okay, now to solve for M2, we're going to do the same thing we did up here. We're going to do the same thing we did up here. All right, so I'm going to do 3.75 times 0.9 over V2, and that is going to be 1.69 molar. Okay. Number 3 is kind of similar. The only thing here is we are looking for final volume. Okay, and I have a 2 molar solution. I have a 0.5 liter volume. My final molarity is 6 molar. So now we're solving for V2, okay? So V2 is going to be M1 times V1 over M2, okay? So that's going to be 2 times 0.5 over 6. Okay, and that's going to be 0.17 liters. Okay, I just kind of cleaned that up a little bit. So down here, what we are solving for is V2. Okay. Okay, for the last 3, it's the same thing. Okay, so just read what you're given and try to figure out what you're trying to find. Okay, so it says what concentration results when you have 2 liters of saline solution prepared from 0.5 liters of a 0.75 molar concentrated solution. So you have to understand these were the initial conditions. And this is the final condition. So what I'm looking for is M2. I'm given V2. This is going to be V1, and this is going to be M1. Okay, so we're going to plug all that in. Okay, and then again, to get M2, you're going to do M1 times V1 over V2. So that's going to be 0.75 times 0.5 over 2. And that's going to equal 0.19 molar. Okay. So in case you're wondering, if you have M1 V1 is equal to M2 V2, okay, algebraically you can manipulate this formula 4 different ways. Okay, so that's all I'm doing here. If I'm solving for this, we're going to divide V2 to each side. Okay, and that's going to get me, the formula that I used right here. Okay. Alrighty. Last 2. Okay, so we have our original is 2.5 molar. Our initial volume is 1.2 liters. My final molarity is 1.75. And my final volume, I don't know. Okay, so if I'm solving for V2, I'm going to have to do M1 times V1 over M1. Excuse me, hold on. Let me show you. So I'm solving for V2, so I have M1 V1 is equal to M2 V2. So to get V2 by itself, we're going to divide by M2 to each side. Okay, so that's what I'm going to do here. So I'm going to do M1 times V1 over M2. And that's going to help me get V2. Okay, and when you plug that into your calculator, you're going to get 1.71 liters. Okay, last one. Our original molarity is 0.88 molar. My initial volume is 1 liter. My final molarity, I don't know. And my final volume is 1.65. So again, to solve for M2, we're going to do M1 times V1 over V2. So that's going to be 0.88 times 1 over 1.65. And that is equal to 0.53 molar. Okay, and that's it for dilutions. Again, just read what you have. What are you trying to find? What's initial conditions? What are the final conditions? And you're basically solving for whatever the concentration or the volume is of either the original mixture or the final mixture.